Here we're going to look at one example, and I'm going to look at it 3 different ways on using my test for parallelograms. It tells me that I have a quadrilateral, and it gives me the 4 vertices of it. And I want to figure out, is this thing a parallelogram or is it just a quadrilateral? Now my recommendation is, let's graph it. And you don't have to get out graph paper. You can just make an approximate one right here. I'm going to take my points, -3, so 3 to the left and 0 up. Here's A. Then I have to go to -1, 3. It's going to be about there. There's B. C is going to end up at 3, 2. And D is at 1, -1. Here is my parallelogram. Now I'm just going to copy this because, like I said, I'm going to do this 3 different ways. So one way to look at it is using our tests. I'm going to just go back to the very basic definition of a parallelogram. The quadrilateral with 2 sets of parallel sides. Well, on the coordinate grid, we can figure out if sides are parallel by using slope. And what I'm going to do is I'm going to look at slope. So M, remember, stands for slope many times in math. Slope of segment AB. Well, I just need to use my slope formula using point A and point B. So I'll do my 3 minus 0 over -1 minus -3. And I find out the slope of segment AB is going to be 3 over 2. So I'm just going to put that up here, remembering in my head that that's the slope. Well, then I'm going to come over and I'm going to want to find the slope of segment CD. So I'll do that right here, slope of segment CD. I'm going to do the exact same thing. Now I'm going to look at point C and point D. Now this time I would do 2 minus -1. Those are my y values, and subtract my, oops, going the wrong order. No, that is right, sorry. Then I'll do 3 minus 1 here, and I get 3 over 2 for a slope of this one. So right now it's looking good that I might have a parallelogram going because I have 1 set of parallel sides. I can't quit there because I have to find the slope of the other 2 sides as well. So now I'm going to look at the slope of segment BC. Now I'm going to look at the coordinates there. So I'm going to have to do 3 minus 2, and then I'm going to have to do -1 minus 3. Subtract my y values, subtract my x values. Here I end up with 1 over -4. So this one has a slope of -1/4. And then I also have to find the slope of segment AD. Subtract my y values. 0 minus -1 over -3 minus 1. I end up with 1 over -4. So I have a slope of -1/4 here. Well, this tells me I have 1 set of parallel sides. This tells me I have my second set of parallel sides. So is it a parallelogram? Yes, it is. So that's one way to prove that a quadrilateral is a parallelogram when it's on the coordinate grid. Now another one would be to look at our theorem that said if a quadrilateral has 2 sets of congruent sides, then it is a parallelogram. So that's what I'm going to look at now. Now when I do that, I can find lengths on the coordinate grid. So I'm going to come back here and I'm going to go, well, let's find the length of segment AB. Well, now this is a distance formula. And I'm not going to go through the full distance formula here because we've done that many times before. If you need a little review on it, either talk to me or look back at a previous lesson. But I've gone through and I've done this already. The length of segment AB came out to be the square root of 13. Put that in here. I used my distance formula to find the length of segment CD. And that also came out to be the square root of 13 log. So again, I'm on a path to say that yes, it's a parallelogram. But that's not enough because remember, I still need to find the length of segment BC and the length of segment AD. Well, again, I have done that already. The length of segment BC came out to be the square root of 17, and the length of segment AD came out to be the square root of 17 as well. Well, I look at my quadrilateral. I have 2 sets of congruent sides, and they're the opposite ones, which is important as well, which tells me that yes, this is a parallelogram. And then I'm going to look at one more method to do it. In this one, I'm going to use the theorem that says if both diagonals bisect each other in a quadrilateral, then it's a parallelogram. Well, to do that, I'm going to look at this diagonal and this diagonal. Those are the two. And my way to check to see if they're actually cutting each other in half is I'm going to find the midpoint for segment BD, and I'm going to find the midpoint for segment AC. If the midpoint for segment BD and the midpoint for segment AC is the same point, they're bisecting each other. Now, if it's two different points, well, then they're not bisecting each other. So now you got to think back to how do we calculate midpoint? Well, I like to think average. So I'm going to have to work with these 2 points to find the midpoint of segment BD. So let's go midpoint of segment BD. I'm going to average my x values. So I'm going to have a -1 plus 1, and then I have to cut it in half. That's going to give me the x value there. And then I have to average my y values. So I'm going to have 3 and -1. Divide that by 2, and I'll have my y value. Well, -1 plus 1 is 0, divided by 2 is 0. 3 plus -1 is 2, divided by 2 is 1. So my midpoint of the green segment, segment BD, is 0, 1. Well, do the exact same thing with segment AC. Now I'm going to look at these 2 points. I want the midpoint of segment AC. Average my x values and average my y values. -3 plus 3, 0 divided by 2 is still 0. 0 plus 2 is 2, divided by 2 is 1. Now I look at this and I see that the midpoint of the green segment, the midpoint of the blue segment, exact same point. That's telling me that the diagonals are bisecting each other, and then yes, it has to be a parallelogram. Which would make sense. If it was a parallelogram on the first one, it should be a parallelogram on the next 2 as well. So those are just 3 ways of proving that a quadrilateral is actually a parallelogram on the coordinate grid. And then that's what's going to conclude my lesson on, or my examples dealing with tests for parallelograms.